Example number 2 of area under the curve. Approximate the area under y is equal to 0.5 x squared plus 1 on the closed interval 1 to 4 and using 6 subintervals. LRAM means left-hand rectangular approximation method. So the first thing we want to note is that we're going to use delta x is equal to b minus a divided by n. My b value will be 4. My a value will be 1. And n will be 6. So our next step will be to set up the formula with the values substituted in and simplify. So we're going to have delta x is equal to 4 minus 1 divided by 6, which simplifies to be 0.5. Delta x is equal to 0.5, which means each rectangle will have a width of 0.5. Let's take a look at the graph of the function on the interval. The graph of the function on the interval creates 6 rectangles of equal width where the left corner of the rectangle is touching the function. So you'll notice we have the first rectangle has a width of 0.5. It goes from 1 to 1.5. And note that the left corner is touching the function. Our second rectangle goes from 1.5 to 2, and also the left corner is touching the function. The third rectangle also has a width of 0.5. It goes from 2 to 2.5, and you'll notice that the upper left corner is touching the function. Finally, you'll notice our last rectangle goes from 3.5 to 4, has a width of 0.5, and you'll also see that the left corner is touching the function. Now we're going to find the area of each rectangle, and we're going to add those areas together to find the total area under the curve from 1 to 4. Now keep in mind that the width is 0.5 for each rectangle, and the length of each is the functional value. So the width will be left and right at 0.5. The length will be the up and down component, which is designated by f of x. So using the left RAM, LRAM, we're going to take 0.5, that's the width, and then the sum of the lengths. So we're going to take f of 1, f of 1.5, f of 2, f of 2.5, f of 3, and f of 3.5. Now, just to point out, the range ends at 4, so why are we stopping at 3.5? Because 3.5 is where the left corner of the rectangle touches the function. Now we're going to find the area of each rectangle and add those areas together. So from before, we knew that 0.5 was equal to f of 1 added up to f of 3.5. Using our y is equal to 0.5 x squared plus 1, we're going to calculate concrete values. So f of 1 will be 1.5, f of 1.5 will be 2.125, f of 2 is 3, f of 2.5 is 4.125, I was thinking 4 1/8, f of 3 is 5.5, and f of 3.5 is 7.125. Adding all those together and calculating the arithmetic, we get the approximate area under the curve from 1 to 4 will be 11.6875. This raises the question, would this be an overestimate or an underestimate of the actual area under the curve? Explain. Well, this would be an underestimate because all the rectangles are within the area under the curve, and there's more area that has not been accounted for. So we go and look up here, we see a little region up here above each rectangle that is unaccounted for. Therefore, the area of each of these 6 rectangles would be less than the actual area, so it is an underestimate.